Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge Igcse Extended Mathematics for October-November 2024 paper 4-1, and this is part 2 for questions from 6 to 10. However, I forgot to do part C of question 2, so that's where I'm going to start from. Part 2 of question 2 in our previous video. So part C for question 2 is saying the point AB is reflected in the line y is equal to k, where k is an integer and b is less than k. Write the coordinates of the image of point AB in terms of a, b, and k. Now let me draw some small sketching here. I can have my axis here. Then maybe this is my x-axis. So this is my y-axis and then this is x-axis. Then I can have a line y is equal to k is a horizontal line. Let's say I put it here. Okay, it is parallel to x-axis. So this is y is equal to k. That means the y coordinate on this line is k. So I can write it as k here. Then I'm going to have a point, let's say here, which is a, b. So this that means here, that is the x coordinate a, and then the y coordinate here is that b. Okay, they said b is less than k. Okay, so that's why I'm putting it below k. Then after that, we are going to reflect it in this line. So when we reflect it in this line, the image is going to be the exact length here. Remember, now this length is going to be k minus b. Okay, in between these two here, k minus b. So k minus b. So even here, the distance will be k minus b. K minus b here. So the x coordinate remains because you are reflecting in the horizontal line. So it will be a, but the y coordinate here, okay, is going to be this k that we are seeing here, then plus this distance here. Okay, that is k plus k minus b. And when you add them, that means we get 2k minus b. So the coordinates of the image are going to be a and then 2k minus b. Okay, so alternatively, how you get the y coordinate, it is going to be this y coordinate, which is b. So I can say new y. Okay, I can say new y. New y is going to be equal to b, then plus the whole of this distance here, which is 2 into k minus b. So you have b, then plus 2k minus b. I mean 2b when you open the brackets. So we shall have 2k, b minus 2b, that is minus b. So it's the same as the other. Question 6. The diagram shows a field ABCD. A straight path AC goes across the field. Show that AC is equal to 1028 meters, correct to the nearest meter. Now, you can see that this length AC, it has an angle that is opposite to it. And then these other two sides that are forming that angle are known. So for that case, we are going to use the cosine rule. Okay. So if a triangle is not right angled, then we can use the cosine rule or the sine rule. How do you know that you're supposed to use the cosine rule? Number one, if the two sides are known and also the included angle, like these ones, this is 830 and then 420, they are known and then the included angle. then that means we can find that side which is opposite to that angle which is given. So we can use cosine rule. The other one is when all the three sides are given. Even this one is given. That means we can find any angle inside here. And then when do we use sine rule? That is when maybe two angles are given and also they are opposite sides. Okay. Or I can have an angle here. Maybe it is the one that they are telling me to find, this angle here. Then the side opposite to it must be known. Okay. And then this other one which is given, the side opposite to it must be known, like that. All right. So here let's use the cosine rule. So I can write using the cosine rule, which states that a squared is equal to b squared plus c squared minus 2bc cosine of a. So our AC here squared is equal to b can be 420 squared, then c can be 830 squared minus 2 times 420, then times 830, and then cosine of the angle which is opposite to AC, which is 106. And then that means that our AC is now going to be the square root of everything here. So I get the calculator and I put in 420 squared, then plus 830 squared. So this one gives me 865,300. Okay, 865,300. And then I can also get 2 times 420 times 830. That one is 697,200. 697,200. Then cosine of 106. Now, a mistake which is usually done here, people get this one, they subtract this, then after they multiply with the cos of 106. No, these are two different terms. So this one is a term on its own and this one is a term on its own. So when I get the calculator, I will put, let me put the square root, then 865,300, then minus 697,200 cos of 106, close the brackets, press equals. So that is 1028 and the rest of those figures, but to the nearest meter it is going to be 1028. 1028. Next, part B, angle ACB is obtuse. Calculate the angle ACB. So angle ACB, this is the one they want us to find, but the side opposite to it is known. Then we know this other angle, and the side opposite to it, we have also gotten it as 1028 meters. So for that case, we can use sine rule. Okay, so here we are going to use sine rule. So using sine rule, which states that A over sine A is equal to B over sine B, which is equal to C over sine C. So here we are looking for angle ACB. So you can also somersault this and you have something like this. Sine of A over A, which is equal to sine of B over B, which is equal to sine of C over C. So I'm going to have now sine of that angle ACB which I'm looking for, then divide by the side which is opposite to it, that is 150. So I have 150, then it's equal to sine of the other angle, which I know, is it 62? I think it is 62. So it is 62. Then the other side is 1028. So divide by 1028. Then I cross multiply. So I will have sine of angle ACB, which is going to be equal to 1150 sine of 62. Then we divide by 1028. So meaning the angle ACB is going to be equal to the arc sine of 1150 sine of 62 degrees out of 1028. So I can put this in the, since this thing is positive, okay, since what we have got here is positive, inside here is positive, then that means we are going to get the acute angle, but they asked for the obtuse angle. So after that, we subtract from 180 because obtuse angles are greater than 90 but less than 180. So we are going to put arc sine, so shift, then sine. Then we have 1150 sine of 20. You need to first check the mode of your calculator. It has to be in degrees. Okay, 1028. Then press equals. So that is 81.0. That is to one decimal place. I can write 81.0. And then the obtuse angle of ACB will be equivalent to 180 degrees minus this 81.0. So I will just come to this one and I say, 180 minus 81. That one will give us 99. So I will write 99.0 degrees. Okay. Then part C, the same part of the field triangle ACD is sold for $41,500. Calculate the cost of 1 hectare of this part of the field. Give your answer correct to the nearest dollar. 1 hectare is equal to 10,000 meters squared. Now, for any triangle that is not right angled, let's say we have A, we have B here, and then we have the angle in between. So long as you know the two lengths and the angle in between, then the area of that triangle is going to be equal to a half those two sides which you know, then sine of the angle in between. Now here we need to find the area of that triangle ACD. So it is going to be a half, then times, we can go to ACD. We know 106, then 420, and then the 830. So those are the ones that we are going to use. Okay, so we shall multiply by 420, then times 830, and then sine of the angle which is in between 106. Okay, so this one I can even just simplify it first there, and I say 0.5 times 420 times 830, it gives me 174,300. So I can write 174,300. I can leave this sign 106. I want to put everything all at once at the end. Then this one is in meters squared. Okay, now if 1 hectare is equivalent to 10,000 meters squared, or you can say 10,000 meters squared shall be equivalent to 1 hectare. So how about maybe 1 meter squared? 1 meter squared will be equivalent to 1 over 10,000. Okay, then hectares. Okay, so that therefore implies that we are going to divide this by 1,000. So this one will be 174,300 sine 1060 over 160 degrees out of 10,000. This will be now hectares. Okay, and each hectare, okay, now the whole of this costs the 41500. So that means I'm going to have here, simplified, it will be 17.4, then sine of 106 degrees. So I will say 17.4 sine of 106 degrees hectares. Okay, these hectares here cost $41,500. Then how about 1 hectare? Okay, so how about 1 hectare? 1 hectare will cost this 41,500. Then we divide by the 17.4 sine of 106 degrees. Then we put this one in the calculator. And when we put this one in the calculator, 41500, then divide by 17.4 sine of 106. Oh, sorry. We are supposed to put a 3. This is 17.43. Pardon me here. There is a 3 here, which we had forgotten. There's a 3 here. So if I include a 3 here, okay, so that is 2476, then 0.90, and the rest of those figures. They said we give our answer to the nearest dollar, so it is going to be 24. First of all, this is 2476.9034, and rest of the other figures. So the nearest dollar, I will round this one off to the 6, so plus 1. That means the answer is going to be 2477. Question 7. A company makes scientific calculators and graphic calculators. Each day, they make X scientific calculators and Y graphic calculators. These inequalities describe the number of scientific and graphic calculators they make each day. X less than 180, Y less than or equal to 90, then X plus Y less than or equal to 270. Then part A, complete these 2 statements. The company makes fewer than dash scientific calculators each day. Now you can see that X is the one for the scientific calculators made. So if they say fewer represents less than. So we have to put here 180 because that is what we are seeing here. You see that? Then they are saying the company can make a maximum of dash calculators each day. So that is the total, okay? Scientific and then the graphic. So that means X and Y have to be added. So we have to come to this one here. So it will be 240. Maximum, that means it is less than or equal. Okay, we use less than or equal. Then part B, the scientific calculators cost $12 to make. Graphic calculators cost $18 to make. Each day the company spends at least $2,700 making calculators. Show that 2x plus 3y is greater or equal to 420. So when they tell you to show that, that is the end result. So there is something that you must put together then to get the what? The last one. So this one they are telling you is the end result, is where you're supposed to end. Now, scientific calculators cost $12 to make. So that means we are going to have, okay, here we are going to have, so 12 times X, because scientific calculators, they're represented by X. So we have 12 times X, then plus 18, then times Y. Each day the company spends at least means greater or equal. So the least they can spend on them is 2,700. So we put greater than or equal to 2,700. Okay, now this one we can divide all through by 6. When I divide here by 6, I will get 2 of x, then here 3 of y. Then how about 2700? When you divide it by 6, you get 450. So greater or equal to 450. So this number is actually coming from what we call linear programming. Part C, the region R satisfies these 4 inequalities: x less than 180, y less than or equal to 90, x plus y less than or equal to 240, 2x plus 3y greater than 450. By drawing 4 suitable lines and shading unwanted regions, find and label the region R as the feasible region. Now, before you start, you should know that when we use, okay, I can use for less than, then or greater than, okay, the boundary line is dotted or dashed. But then for less than or equal or greater than or equal, the boundary line, because the values on that line are also included, so the boundary line is solid or bold. Okay. Then for lines like this, horizontal, the region above represents the greater than, the region below represents less than. Then for lines like this, vertical ones, okay, for vertical lines, then this side here on the right represents the greater than, then this one the less than. So it can be less than, okay, or greater than or equal, okay. So in fact, let me use or equal since I'm using bold lines, okay. So this can be or equal or equal or equal or equal. And then for slanting lines, okay, we can have this side above is the greater than, this side below that line is the less than, okay. As simple as that. Now for this one, x less than 180, this one will be dotted, okay. You remove the inequality sign, you put equal signs to know what we call the boundary line. It is the line that separates the two regions. One is unwanted, the other one is wanted. So this is our boundary line. Now, let me write it here. Boundary. It's the boundary line. Now, we got 180. X is equal to 180. Now, what is the equivalence of a small box? Down here, one small box is equivalent to, we are adding on 50 every now and then, so 50 divided by 10, that will now be 5. So we need 180. So this will be 55, okay. This will actually be, no, we are looking for 180. So this is 150, then 60, 70, 80 here. So I'm going to draw that line. This line here. The line is going to be here. But remember, this one is less than, so that means the line has to be dotted. So let me dot it. If you draw it solid, you get it wrong because they used less than. We only use dotted when it is less than or equal. Then you can label that line. This is x, which is equal to 180. You don't say x less than 180. Then we need the less than part. So the less than part is this other side, this one here, the left. So what are we then going to do? We are going to shade off this other part here. This is the one which is greater than. So I shade it off. Then next we can go to we have y less than or equal to 90. That means this one is going to be y is equal to 90 as the boundary line, and this one is going to be solid. Okay, this one is going to be a solid line. So let's check y is equal to 90. So y is equal to 90. Here, even on the y-axis, 1 centimeter, one small box is equivalent to 5. So this is 60, 60. This one is going to be 60, then 70, 80, then 90. So two small boxes below the 100. So I will get this one here and I draw that line. You get your ruler, don't use your free hands. Then this one is bold. So I label this one y is equal to 90. Okay. Then we need the region which is less than or equal. That means the one which is above, we put it off. Okay. The one which is above, we put it off. So I'm going to shade off this region. This one here. We shade it off. Like that. Continue, shade off all of that region off completely. So that is what we have there. The next, we have x plus y is equal to, this is x plus y, which is equal to 240. This one is also going to be solid. So what do I need to do? I need to get a few coordinates here. So I can have my x, then my y. When x is 0, so put 0 where there is x, so y will be 240. And then when y is 0, x will also be 240. So I will come to this one here, and 240 will be here. 240 down will be here. Then I will get my ruler and then the pencil. Okay. And then you draw. You connect this one here like that. Okay. Then we need the part that is less than. That means the part that is greater than. We can also label this one here. This one is y. Sorry. It is x plus y, which is equal to 240. Then the part which is greater, we shade it off. So this one here, we shade it off. Like that. And then we are left with 2x plus. Even this one we can, I can find just two coordinates. So the boundary line is 2x plus 3y, which is equal to 440. And this one is going to be also a solid line. So if I have x, what is y? If let's say x is 0, and you put 0 here, then you divide all through by 3, and you will get 100 and what? 150. Okay. So we get here 150. And then if y is 0, put here 0. So 450 divided by 2, you get 225. So I have 225. Now I come and plot 0, 150. 0 and then 150. This is the point here. Then the other one is 2250. 225. This is 200, 210, 220, 205 is here. Then I connect those ones. So get your ruler, place it here, then also here. Then this one you can label it also. It is 2x plus 3y. Okay. This is 2x plus 3y, which is equal to 450. So they want the region which is greater than. That means this one below the line, I will shade it off. So for this one, I will shade off this. You just shade like this. You don't need to do art here. This is not art. Okay. So our feasible region R is this one here. Now part D. Scientific calculators are sold for a profit of $10. Graphic calculators are sold for a profit of $30. Calculate the maximum profit made by the company in one day. Now, if you want to get maximization, you look around the extreme points. Okay. For maximization, look around the cost, the extreme regions. So, what you have to do is to find out the cost. So the cost equation is going to be, we don't know how many X calculators are there, but each of them costs, scientific calculators, but each of them costs 10. So that will be 10X, then plus, this is 30Y. So I can get a table here, and then I find the cost for a few values around the extremes. Okay, just like that. And I can have here X, Y, and then here the cost, which is equal to 10X plus 30Y. Now, when we go here, let me try to zoom it a little bit. So, any point that is on this dotted line is not considered, okay? Is not considered. And then the points on these solid lines, for them, they are taken. So I can take, let's say, a point here, but let me use another color such that you can keep track. I can take this point here, okay? That is 150.90. I can take 150.80, maybe this one down. This is 150.70, but I need for maximum, so I will need only those 2 points. And then maybe I can also take this one here. Maybe I can also take that one there, and this one is this 150, 160, 175. So this one is 175 here, okay, for the X. Now the coordinates for these, and of course the Y coordinate that corresponds to this one will be 165, okay, 165. Then to find the maximum cost, so these are my points, 150 and 190. So I can put 150, 150 and 190, 150, then not 190, it is 90 and 90. Okay, yes, it is 90. Even this one is not 165 here, it is 65. Okay, this one here is 65. Now I can now substitute here, and I say 10 times 150, then plus 30, then times 90. So what do we get? You put this one in the calculator. 10 times 150, that is 1500, and then plus 30 times 90. So that one will give us 4200. Then next we can use 150 and 80. Okay, I've told you here 150 and 80 is here, then there is also 90. Okay, 150 and 80. Already 150 and 90, we have taken it. So 150 and 80, what do we get? This is 10 times 150. That's also 1,500, then plus 30 times 80, which is 2,400. So we can now have inside here, we just change and put 80. That is 39. Of course, it was expected to be lower because 80 is smaller than 90. Then next, we can go to this other one here. This one here, 175 here, and then the 65. So 175 and 65. 175 and 65. Then we see. So this is 10 times 175, then plus 30 times 65. So putting this in our calculator, we have 30 times 65, and then this other one is 15. And this one is going to be 1750. So that will be 3700. So this is 3700. So the maximum of this is 42. So that means we shall put 4200. Number 8, part A, f of x is equal to 7 minus 3x. G of x is equal to x squared minus 16. Roman 1, find the values of x when g of x is equal to 20. So here, these are functions. So this is function valuation. You just substitute here. X squared minus 16 is equal to 20. Then I can take the 16 this side. So we have x squared, which is equal to 20 plus 16, that is 36. And then x becomes the plus or minus the square root of 36. Whenever you take square root, remember to put plus or minus. Then this one will give us negative 6 and then positive 6. Then the inverse of the f. Let the inverse of f be y. Then I can take the f this side, so that means x is going to be equal to the f of y. So where there is x in the function f of x, I'm going to put y. So I will have 7 minus 3y. Then make now y the subject. So I can bring it this side to be a positive 3y, which is equal to 7 minus x. Then after we divide all through by 3, 7 minus x over 3. So our answer here is 7 minus x over 3. Alternatively, you can present your answer like this. Some people can have x minus, is equal to 7 minus 3y. Then they say x minus 7 is equal to negative 3y. Then they divide all through by negative 3y. By negative 3. So that means their answer is going to be x minus 7 over negative 3. So that one is also accepted. They are the same things. Then Roman 3, find gf of x plus 1, giving your answer in the simplest form. So gf of x means compose f into the g. Put f of x into g. So if we have g of x, then we also have f. This g of x here is the same as, gf of x is going to be g. Then we'll put the f into the g. You see that? So putting f into the g, we are going to have, you go to g and you put f. So we shall have f of x here. Then you square it, then minus 16, because this is the g of x, okay? And then we shall then add a 1, okay? We shall then add a 1. So let me put off this one here. So we add a 1. Now this one will give us f of x is 7 minus 3x squared. Then minus 6 plus 1, that will be minus 15. Now this one, you square the 7. That one will give us 49. Then minus 2 times 7 times 6. 2 times 7 times 3, that is 42 of x. And then you square 3x. You will get 9. Okay, x squared. Then there is this minus 15. So that means we are going to get our answer as 9x squared in decreasing powers of x, 9x squared, then minus 42 of x, then plus 34. You get 49 minus 15, you get 34. Then Roman 4, on the axis, sketch the graph of y is equal to g of x. On your sketch, indicate the values where the graph crosses the axis. So, on x axis, okay, y is equal to 0. So for g of x, remember g of x is x squared minus 16, which is equal to 0. So our x here is going to be equal to 6x squared is equal to 16. Then we take the square root. So it is plus or minus the square root of 16, which is plus or minus 4. That means we shall have 4, 0, and then negative 4, 0. So let's say this is 4. Then this side we have negative 4. And then on y-axis, we know that x is equal to 0. So if you have y, which is equal to x squared minus 16, when x is equal to 0, then y is going to be that negative 16. So maybe negative 16 is this other side. Another thing, this y equal to x squared minus 16, it is the same as y is equal to, so y is equal to 1x squared, then plus 0x, then plus 0. So in this format, ax squared, then plus bx plus c, this is the quadratic, okay? This is the quadratic curve. So since a is greater than 0, the graph has to be U-shaped. And if a is greater than, is less than 0, the graph is going to be N-shaped. So this one is a positive one. So we are going to have a U-shaped curve like this. Something like that, U-shaped. Roman 5, find the equation of the tangent to the curve of y is equal to g of x when x is equal to negative 3. Now, the tangent and the curve, we have our curve here. Then maybe when x is negative 3, a tangent is that line which cuts the curve at only one point. Now, the gradient between any 2 points on the line is always constant, okay? And remember, we say change in y over change in x, okay? But the gradient on any point on the curve, okay, is always different. So that means at the point of intersection, the gradient of the line and that of the curve, okay, are equal, okay? And we use differentiation to find the gradient of a curve. So gradient of the curve is going to be equal to the gradient of the tangent. So gradient, let me just say gradient of tangent is going to be equal to the dy dx when we differentiate. So if you have your y, which is equal to x to the power of n, then differentiating this with respect to x is going to give us, drop this power, n, then x, and then reduce the power by 1. So remember, our y is x squared minus 16. So when you differentiate, drop the 2, then reduce it by 1. 2 minus 1, that is 1. So we have that. And when x is equal to negative 3, so for x is equal to negative 3, then what is dy dx? So dy dx is going to be 2 times negative 3, which is negative 6. Now, using y, which is equal to, we also need to find the y coordinate, okay? Because if you are to find the equation of a straight line, you need the gradient and then at least one point through which the line passes. So y is going to be -3, then squared, minus 16. This is 9 minus 16, which will give you -7. So the equation of a straight line is y is equal to mx plus c. And now here we are going to have -3, -7. So where there is y, put -7. Where there is m, the gradient, put -6. Where there is x, put -3. Then our mandate is to find the value of c. So this is -7. And this one will be equal to +18. A negative times a negative, you get a positive. Then -7 minus 18 will give us the c. And our c becomes -25. So that means the equation of this straight line, the tangent, is going to be -6x minus 25. Then part B, h is equal to 3 to the power of x. This is what we call an exponential function. Okay. Then Roman 1, on the axis, sketch the graph of y is equal to x. Now this one, I can just show you a few coordinates here. We have x, okay, and we can also have y. So if x is, let's say, a -1, so you put -1, that is 1/3, which is 0.3 recurring. Okay, 0.3 recurring. So I can just put 0.3 and with a dot. Then if I have 0, 3 power 0, you get 1. Then 3 power 1, you will get 3. 3 power 2, then we have a 9. So that means when x is negative, this side, it continues to reduce, because if you have 1/3 to the power of 10, it is going to be a very small thing. But there is no value of x you're going to put here on 3 and then it gives you a 0. Okay, it just tends to a 0. Okay, so when x is negative, we have something like this, 1/. So if I put maybe 10, this is a very big value. Okay, let's say you have 1/, then 3 power 1. Okay, that one is 0.3 recurring. But if I come to this one and I put, let's say, power 5, this one will give me 1/243, which is 0.004, and the rest of that. Then when I increase this power, now let's say to 8, okay, it will be 0.00. So it tends to a 0. Okay, it tends to a 0. How about when I put 20? You see, it is 0.0000. You put 9 zeros before the 2. So that simply implies that there is no, it just tends to the 0. Okay, but it never becomes 0. So and that is the y value, and we know that on x-axis y is 0. So that means the x-axis is an asymptote. The line doesn't, the curve doesn't cross it. So that line which is not crossed by the curve is called an asymptote. So I need to just put here a 1. Then I draw my curve just like that, and then I follow this line here, like that. So that is how it is going to look like. Then Roman 2, write down the equation of the asymptote. You see, asymptote they are telling us. So let me write it here. An asymptote. An asymptote is a line that doesn't intersect the curve. So they said the equation. So this is x-axis, but the equation of x-axis is y is equal to 0. Question 9, we are given a cuboid here. AB is 10, BC is 8, and then CG is 17 centimeters. Work out the volume as part A. Volume of the cuboid is equal to length times width times height. So here we shall have 10 times 8 times 17. So what is 80 times 17? 10 times 8 times 17. That is 1360. 1360. 1360. Next, work out the surface area. The surface area is the sum of all the areas of the faces on that given shape. So this part here is the same as this one, this side. Okay, so those are 2. Then this one facing us here, the ABFE, is equal to the HDCG behind. Okay, and then we also have this one up here, EHGF, is also the same as ADCBA. Okay, that one there. So we can see that if this is our length, this is width, and then this is height. So the total surface area, is now going to be equal to, twice, then length times width. We also have length times the height, then we have width times the height. So this is 2 because we are seeing two faces. Okay, length times width, that is 10 times 8, and then length times the height, that is 10 times 17, and then width is 8 times the height, 17, and then 8 times 17, that one gives us 136. So we have 2 into, this is 80, 170, then plus 136. So when we add all of these ones, 80 plus 170, then plus 136, we get 386, then times 2, you get 772. So this one is going to be 772. Then next, calculate the angle between GA and the base AB and the base ABCD. GA, that is what we call the diagonal of the cuboid. So I can connect this one here. Let me use a ruler, connect this one to that. Okay, and then I will pass through this one down here. Then I will go through this diagonal here. So they want us to find the angle between. So it has to be this one here. So we need to find SC here, and this one is the base. So we are going, this angle here is 90 degrees. Okay, so we are going to use, just like you are seated there in your room. Okay, you look at one corner up, and then you look at the opposite corner but down. So suppose you put a string or a rod connecting the lower part of this other side, and then this other side, and then up this other side. Okay, so that's what we are talking about here. So we are going to use Pythagoras theorem. Look at this triangle here. Consider this triangle ABC. Okay, triangle here ABC. This is A, B, and C. Our AB is 10 centimeters, and then this one is 8 centimeters. So using Pythagoras theorem, then SC shall be equal to the square root of 10 squared plus 8 squared. 10 squared is 100, then the other one is 64, so square root of 164. You can leave it there. Okay, then I'm now going to have this one here, a new triangle. Already we have seen that this is A, this is G, and now this is C here. So our SC is root of 164, and then GC up here is 17. So this is 17. Okay, Now, this being a horizontal face ABCD, and then DCGH is a vertical face. That means the angle in between these two is 90 here. So now we are having a right angle triangle there. And remember, when we have a right angle triangle, we can use SOHCAHTOA or the Pythagoras theorem. Now here we are going to use SOHCAHTOA, okay, using our acronym SOHCAHTOA, which represents the relationship between the trigonometric ratios. So this is opposite to the angle, the side which is far away, and then this is adjacent. So here we are going to use the tau, that is tan of that angle is equal to the opposite 17, then out of root of 164. That means theta is going to be the arctan of 17 out of the square root of 164. And then what I can do here is to get shift, then turn, and then I put 17 out of root of 164. Then this is 53 and the rest of those figures, but to one decimal place, this one will be equal to 53.0. That is to one decimal place. Then next part D, a straight rod PQ is placed inside the cuboid. One end of the rod P is placed at the midpoint of AB. The other end of the rod Q rests on GH. HQ to QG is equal to 4:1. Now, the total ratio here is going to be 5. So I can begin by finding HQ. This one is going to be 4 out of the total, which is 5, then times what is HG. HG here is the same as AB, so times 10 here. So times 10, this one will give us 8 centimeters. That means this one is 8 centimeters. And of course, QG has to be 2 centimeters. If you get 1 over 5, then times 10, you get 2 centimeters. So this will be 2 centimeters. Calculate the length of the rod PQ. Now to find the length PQ, I'm going to connect this one here, okay, here, then down. So PF, then connect this one directly down, okay, to this face here. Then you also connect it here. So we need PF. But then, of course, this length here is 17, okay? This length here is 17 centimeters, which is vertical. And then we need this length here, PF. When you look at this one here, remember this is 8. So that means if I can take this one directly just like that, okay, this one from here up to here is also 8 centimeters. In fact, let me try to follow this one here, so to be parallel, so it will have to be like that. So this one will be 8. Let me repeat this. This one here, try to follow just like that. So this is 8 centimeters here, but P is in the middle. So if this is 5 centimeters, then that means this is 3 centimeters here. Then this will be 8 centimeters. You see that? 8 centimeters here. Now I have this triangle here. This triangle here is right angled, okay, because it is on the base here, okay. It is just slanting like this one here, this face here, but because this is 3D. Now we are going to have our triangle here like this. Let me use blue. So we need to find This one here, I can label it maybe with any other letter, GH. I can maybe put K here. So I can have P, then K here, and maybe this is L here. So I can put L here. So this is 8 centimeters. This is 3 centimeters. We need to find PK. So using Pythagoras theorem, it will be the square root of 3 squared plus 8 squared. 64 plus 9. That one gives us 73. So root of 73. Now, we can bring this one and we say this other one, which is going to give us P. PF. So PF, then K, okay? And PK, we have gotten it as root of 73. So we need PF, but F to K is 17. So using Pythagoras theorem, this PF is now going to be equal to the square root of 73 squared, then plus 17 squared. So 17 squared is 289. So we shall have 73 here plus 289. When you add those two, you get 362. So root of 362. You can give your answer like that, or you can say root of 362. You get 19.0. That is to 3 significant figures. So I can write 19.03 significant figures. Question 10, part A, we are given a rectangle which has the area 190 centimeters squared. Roman 1, by forming and solving an equation, show that x is equal to 8.5. Area of a rectangle. Area of rectangle is equal to length times width. So length times width. So that means we shall have 2x plus 3. We multiply by x plus 1. Then this one will give us 190. So 2x times x, we shall get 2x squared. Then 2x times 1, we shall get 2x. Then 3 times x, we get 3x. And then 3 times 1, you get 3. Then bring the 190 this side is equal to 0. So meaning we have 2x squared. Then 2x plus 3x, you get 5x. And then 3 minus 190, we get negative 187, which is equal to 0. Then you can use a calculator or the quadratic formula. So when I use the calculator, equation is 5, then 3, that is where we have quadratic. I put 2 equals, then 5 equals, then negative 187 equals. So I get 17 over 2. So I can skip space and I write x is equal to 17 over 2. And then the other one is negative 11. So x is equal to negative 11. But if you just write this, you will lose a mark because they will tell you attempt to solve the quadratic equation. So there they give a mark for it. You can use the quadratic formula. You can use any method you want. Completing squares, factorization. But here what I'm going to do, cross multiply. You need to give us the factors from which these roots come. So when I cross multiply, I will have 2x. Then take the 17 here. You have negative 17. Then this one, you bring the 11 this side. So it will be x here plus 11. And then is equal to 0. So 17 over 2, that is 8.5. So since x here is a length of this rectangle, it is not going to be a negative because length cannot be a negative. Like here, we shall have negative 10. No. So that is why we are taking only that value. Work out the perimeter of the rectangle. Remember, this side here is equal to this one. Then this one is equal to this. So what do we then do? Summing up all of that, perimeter of a rectangle. Okay, perimeter of a rectangle is equal to twice, then length plus the width. So we have twice, the length is 2x. 2x plus what? 2x plus 3. Plus 3, then the width is x plus 1. Yes, x plus 1. So that means inside here we have 3x, then plus 4. Now you can bring your x, which you got 3 times 8.5, then plus the 4 here. Then get the calculator. Odd, put 1. So we shall have twice of this will be 4 plus, then 3 times 8.5. So this one will give us 59. So that will be our answer, 59. Then part B, the diagram shows a sector OAB of a circle with center O and a chord AB. The shaded segment has area 30 centimeters square. Show that R is equal to 23.7 centimeters, correct to 1 decimal place. Remember, this is our end result. We are given the area of the shaded region. So how do we get area of that shaded region, the segment? So area of segment is going to be equal to area of the sector, then minus area of the triangle, So this is the sector, and then this is the triangle. So we subtract the two, and we can see that the triangle here is not right angled, but here we have R, then we have R here, and then the angle in between. So just like before, then area of such a triangle is a half times this R times this R, then sine of the angle in between. Okay, so we are now going to have area of the segment is given as 30. Area of the sector is the angle the arc subtends at the center of the circle divided by the total angle in the circle, which is 360, then times pi r squared. Okay, times pi r squared, because a sector is part of the circle. So the amount of space taken by a sector is just a portion of that of the full circle. Then minus area of the triangle is going to be a half times r, then sine of that angle, 50 degrees. So we can have 30 here. Then this one can be 5 over 36 pi. Then we can also have sine of 50 here over 2, then r squared. So making r the subject of the formula, we can have, this is 30, we divide all through 3 over, no, it's not 3, it is 5 over 36 of pi, then minus sine of 50, then over 2. Then after that, we can take the square root. Then that will give us the r. So when we put this one in the calculator, we are going to have the square root of 30, then we divide by, we have 5 pi here out of 36, then minus, we have 0.5, which is a half, then sine of that 50. Yes, then that gives us 23.7, and the rest of those figures, but 1 decimal place, that is 23.7. So r is equal to 23.7 centimeters. And then the last question of the paper, calculate the perimeter of the shaded region. So the perimeter of the shaded region, we just have the straight edge here, the AB, and then the arc length AB. So those are the ones that we need to calculate. Now, since this one is known and this one is known, then the angle in between them is known, and also the side which is opposite now is the one that we are looking for. Then here we can use the cosine rule. Okay, so using the cosine rule, we need to find the straight edge AB. So it is going to be actually the square root. These other two sides, they are known. So r squared, I can take it as 23.7 squared, then plus, again, 23.7 squared, minus 2 times 23.7 times 23.7, then cosine of the angle that is opposite, which is 50 degrees. Okay, and then this one will give us a certain value. So we can put it in here, and we say square root 23.7 squared plus 23.7 squared 23.7 squared, then minus now 2 into 23.7 squared, then cos of 50. So I put it all together at once, and that one will give me 20.0321, and the rest 20.0321. Okay, I take it as that. And then arc AB, length of arc AB, the angle it subtends at the center, which is 50 out of the total angle sum in the circle, then times 2 pi r. Okay, 2 pi r, and r is 23.7. So why am I using pi r? This arc here is part of the circumference of the circle, so it's a portion of the circumference of the circle. So therefore I use the equation, the expression for the circumference of a circle, which is 2 pi r or pi d. Then putting this in the calculator, we can have 50 out of 360, okay, then times 2 pi, then times 23.7. So this one is going to give me a certain value, okay, which is 20. In fact, let me go 79. This one is 79 over 12 pi. 79 over 12 pi. That means the perimeter of the segment, that shaded one, is going to be equal to straight edge AB, then plus the arc AB. Okay, the arc. So we are going to have 20.0321 whatever, then plus 79 over 12 of pi. So I just get my calculator here and I say plus, then 20.0321, and then to three significant figures I'll write 40.7. 40.7. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. Where need be, please drop a comment. See you in the next videos.